Aloha, this is just a real quick um, idea of an experiment for flat earthers to do or look into that I haven't seen done before. It was all sparked from this one image that you're looking at right now, talking about a basketball being flat or something like that. Well, it triggered the idea, and a channel I would recommend checking out is Phuket Word. He does real quick, straight to the point, scientific experiments based upon all kinds of different observations, like perspective, on his channel. Check out Phuket Word. I'll probably send this over to him and see if he's interested in doing it. So basically what it is that you can get something like one of those workout balls, like a yoga ball or something like that, to make it easier to see. But you take a camera just like this image and you zoom in real close till it's flat. And what you do is you take the scale of the earth and you make the you run the math to the scale of the ball, or you take you mathematically equate the scale of the ball to the scale of the earth. And then based upon the height of the camera, you take the scale of inches and convert it into feet. And you raise the camera however many inches, and however high you raise that camera will equate to how high you should be able to see curvature when you see the scale of raising in feet on like a plane. So my theory is when you raise that camera, not even high at all, what'll happen is that you'll start to see some kind of curvature. And even in this basketball image, you can still see curvature even though they're claiming it's flat. So it's not going to take a much height at all to see this. This is mostly just for like posterity. It's just to get it done and people can see mathematically, scientifically that, you know, this is a thing that you can do because it's real math. So once again, you take that image, or you take a big ball, you zoom in close with the camera, and then you raise the camera on the tripod a few inches, and then you should be able to see the curvature immediately. Actually, you'll see the curvature immediately once you start raising that camera. And since the math in inches equates to the feet of like being in a plane, you should be able to see some kind of curvature, or you will be able to see curvature, obviously, but that should be a proof of like the height, the exact height that you should be able to see curvature, because that's where the actual curvature math comes from. It comes from like, what is it, 8 inches per mile squared or something like that. So that's an actual scientific thing that could be tested. Supposedly it should be able to be tested to scale. So if that can happen on an earth that's supposedly a globe, then you can, to scale, raise and lower a camera that's zoomed in like real close to that horizon, and you'll be able to see it. So I just wanted to throw that out there for people. I mean, just even talking about it, people can imagine that once you raise that camera, you're going to be able to see some curvature. And when you're up 30,000, 40,000 feet in a plane, you should be able to see something, just like how you could see some little bit of curvature on that basketball, even at the edges. The same thing should be for the globe. So yeah, anybody who's interested in doing that math and setting up that whole thing, I'd be interested in seeing it. And to me, like it seems like everything should line up. Like if you have the scale of the earth, you should be able to mathematically say, all right, well, this is however many thousands of, miles around. Well, this ball is however many inches or millimeters around, and each millimeter represents a few feet or whatever that is. So it makes sense to me. I would recommend checking it out, doing it is another way to put that information out there. So thank you for joining me. Like, once again, check out Phuket Word. He does videos like that. If you're listening, I would love to see that experiment. So thanks again. And until next time, from all my relations, peace, love, and harmony.